Powers of binomials. Two questions here for you. Those two. X plus y quantity squared, x plus y quantity cubed. Now, if those two are too tough for you and you want to start off with something simple, I got you two. I want you to start with 3 squared and 3 cubed. Well, that was a terrible 3. Okay, let's start with the easy ones. What's 3 squared? 9. Why?
3 times 3.
3 times 3. In unison? That was adorable. Okay. What's 3 cubed?
27.
27. Why?
3 times 3 times 3.
That was not as much in unison, but we'll still go with it. 3 times 3, which equals 27. Fantastic. So, for x plus y quantity squared, what do you got to do?
Is this whenever you multiply? Is this is it usually what's in front of the x?
With.
One of this would be parentheses x plus y and then another one x plus y.
Yes.
Okay.
See, most, and you can subtly erase, and I'm not going to call you out here. You can subtly erase and just be like, oh, I screwed this up, if you put x squared plus y squared. Okay, so go ahead and subtly erase right now. Don't worry, nobody's watching. But the reason why is because all those rules we learned in the first section were with monomials. Okay, and I probably skipped over that very quickly, that these were rules for exponents with monomials. But x plus y is a what? Binomial. Okay? So everybody just wanted to go square x, square y, done. You're not doing everything. Because you got to go back to this up here. 3 squared means do 3 times 3. 3 cubed means do 3 times 3 times 3. Same thing with your binomials. Shields. No. What you need to do is x plus y times x plus y. And then you what? FOIL! No homework tonight. X times x. X times y. Y times x. Alphabetically. xy plus y times y. Y squared. Whoops. Add the terms in the middle. X squared plus 2xy plus y squared. Yes?
Yep.
Yeah.
Okay.
I have a question.
What's up?
If it's not in alphabetical order, is it considered wrong?
Wrong is the wrong word. I think you're making it tougher on yourself, Megan, if it's not in alphabetical order. I think as long as you stay consistent with the order you put them in, which for the simplicity reasons we always say alphabetically, I think that's the main focus of it, because you might, if you do like x, y on the first term and then y, x on the second term, people often miss that those are like terms. So you want to get them the same, and just to be consistent throughout, we always just say do alphabetical. Okay, makes sense? Okay, so x plus y quantity cubed, you do it the same way, except we have x plus y times x plus y, and then we had to throw in an extra x plus y, yes? So I'm going to pick up, so you do this one the same way. FOIL the first two, which I'll pick up from right here, right? Everybody good with that? And you need to times that by one more, x plus y. Okay, which kind of turns into your binomial times trinomial questions from last lesson. Okay, last section. So now you go through that rigmarole of everything. As you get practice with it, you can kind of skip over the writing it out, and you can just go, x squared times x times y, 2xy times x times y, and just go straight to your 6 terms here. Everybody understand what I'm saying? So x squared times x gives you x cubed plus x squared times y is x squared y plus 2xy times x is 2x squared y plus, I'm going to run out of space, 2xy times y is 2x y squared plus y squared times x is xy squared plus y cubed. It is. Okay, last thing to do, you got like terms all over the place, right? We have an x cubed here. We have x squared y and 2x squared y, which gives us 3x squared y plus, we have a 2xy squared and 1xy squared to give us a 3xy squared and one more y cubed term. And that is your final answer. Does that all make sense, everybody? Great. So that's basically what we're doing today. We're doing today and tomorrow, I guess, because it is a 2-day lesson. We're going to take all these different binomials and take them to all different kinds of powers. We're going to go to the thirds, to the fourths, to the fifths, to sixths, to sevenths, to eighths. Cool? Great, yeah. So get your foiling pants on. Or let's do something else. Yes.
How long are class periods?
It's like half an hour. Like they're exactly like today. Okay. Next. Okay. Now, instead of come on. There we go. So, here are your x plus y's all the way through to the fifth power. Everybody see that? Don't write this left side yet. Just watch me do my thing real quick, okay? So, basically, yes, there is a shortcut to this, okay? This shortcut is called Pascal's triangle. Pascal was, I believe, a Chinese dude, and he figured out that there is a correlation to your coefficients when you expand your binomials out. All right? So they start Pascal's triangle at the very top. And they, whoops, wrong button, backing up. They start at the very top, x plus y to the 0 power. Now, you guys know anything to the 0 power is and always will be what? 1. Very good.
Wow.
We're on fire today. Okay. Now remember, Pascal's triangle makes the coefficients. Okay, so x plus y to the first is just x plus y. The coefficient of x would be 1. The coefficient of y would be 1. You can, yeah.
Should we?
You can maybe wait just a little bit, but I would start writing the triangle, yeah. Okay. Now, x plus y squared. We just did that. What were those coefficients? In order. 1, 2, and 1. Right? Because your answer was x squared plus 2xy plus y squared, right? 1, 2, 1. We just did x to the third. What were those coefficients? 1, 3, 3, 1. X to the third, or x to the third plus 3x squared y plus 3xy squared plus y cubed. 1, 3, 3, 1. I will tell you that x to the next line is 1, 4, 6, 4, 1. I want you guys to figure out the last line up there. X plus y to the fifth. Look for a pattern. Okay, so we figured out we have 6 numbers because your exponent, it's always one more. And we figured out that we start at 1 and we finish at 1. That's a plus. Now, how do we come up with the middle numbers? Ricky, which 2? Not quite.
One of the little ones not.
No, one of the middle ones is not 9.
I said 7.
Is 5?
Which one's 5?
Is the second to last and the second one 5?
Yes. We got winners here. 5 and 5.
One of them 10.
One of them is 10. Which one, Megan? The left one that's left or the right one that's left? Right one. She says the right one that's left is 10. Anybody got the left one? I'll help you out. It is also 10. Okay. I'm going to give you the last row, the 6. Okay, ready? It's 1, 6, 15, 20, 15, 6, and 1. Anybody see a pattern?
I only see the pattern on the outside numbers. I don't pick the middle ones.
Yes,
Okay.
It goes 2, 3, 4, 5, 6.
Right, yeah. The second, everybody can see that. The second lines go 2, 3, 4, 5, 6. It would go 7, 8, 9 on down the second column, I guess you want to call it, second diagonal on this side, second diagonal this side. Everybody see that? Yes? But then you get into this little pyramid right here with the 6, the 10, the 10, the 15, the 20, and the 15. Everybody see that?
yeah.
Okay. There is really no rhyme or reason for that except for this.
Well, if you add the 3 and 3, you get 6. When you add the 10 and 10, you get 20. Does that matter?
Wow. Apparently there is a rhyme or reason.
I see 3 to 6.
What's 1 plus 2?
3.
What's 2 plus 1? What's 1 plus 3?
4,
3 plus 3?
6.
3 plus 4?
Oh. Oh.
Wow, he must be really intelligent.
First, I thought you were talking about Mr. Bowman.
Yeah, no, she's not talking about me. She's talking about Pascal. Thanks for that. But anyways, yeah, but that's how it works. You add the 2 numbers prior. Okay, so your left side starts with 1s, your right side starts with 1s, and then you add the numbers prior, and they make your next number. So 1 plus 3 gives you 4, and then you go again. 3 plus 3 gives you 6, and 3 plus 1 gives you 4, and then another 1. Same way. 1 plus 4 gives you 5, 4 plus 6 gives you 10. Now the tricky ones are here in the middle. Okay, and that's kind of where you have to pay attention to how many numbers you're supposed to have. Okay, everybody see that? Because you just go 4 plus 6, and then, okay, everybody see that? Okay, so that's how it makes. Now, that same concept gets used on the way down the line. So the 7th, the 8th, the 9th, the 10th, you can write this triangle out as large as you ever feel the need to by that logic. Okay? Does everybody make sense? Does that make sense on how you come up with that?
Yeah.
Okay. So instead of now taking, if I asked you guys the next to the 4th question, and instead of foiling it out 4 times, you can apply Pascal's triangle and immediately get the coefficients that they're supposed to have. The only thing we've got to figure out now are what are supposed to be the exponents. Which this slide, which will come up eventually for you guys, this slide here is what we're going to do. So, kind of watch me work this, all right? Here's the only bad part about this. There's 2 bad parts, I think. Number 1, these answers are long, as you can see. Okay, these answers are long. Second bad part to this is it's much more conceptual than you guys think it is. Because that's all the work I'm going to show is what's right there. The end. Okay? So here we go. The last row you wrote down was x plus y to the 6th. Okay? So those coefficients are going 1, 6, what's next? 15, right? 15, 20, 15, 6, and 1. Everybody see that? I probably should use a different color than black, but I digress. Okay? Now, the trick here then is to figure out your exponents. Okay? Now, to do that, visualize 6x plus y binomials. Okay? One right here, 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 and here. Everybody got them in your head? Okay? Great. We'll start here with these 2. When you FOIL these 2 out, and you do x times x, what does that give you? X squared. Okay, ignore the rest. You have this trinomial now times your next binomial, right? When you do that x squared times that x, what does that give you? X to the third. Okay. X cubed. Okay, ignore the rest, go to their next binomial. X cubed times zx is going to give you what? X to the fourth. Ignore the rest, go to the next. X to the fourth times zx. X to the fifth, and then x to the sixth. So on your starts of your FOILs, you do that x times that x times that x times that x times the x times the x to give you this x exponent of x to the 6. Is that it? Yeah. Makes sense? Now, apply the same logic on the back end. All them y's hanging out the end of those binomials, those also will be what? 6 of them, so this is at the end is y to the 6. Okay? Yes, this exponent starts and finishes each one. Okay? Now, I didn't say this and I missed this 6 hour also. Does it make sense that x goes first and y goes second because it's first in the binomial and second in the binomial? Makes sense? Yes? Okay, great. Now, I want you to look back at your past 2 examples that we did. I think if you can apply this logic and expand it. Your x squared answer when we squared those binomials was x squared plus 2xy plus y squared, right?
Right.
Okay. And when we cubed them, it was x cubed plus 3x squared y plus 3xy squared plus y cubed, right? What's happening here? What's happening? We need to know the exponents. That's what we're missing. Yes, everybody see that?
Yeah.
Okay, we need to figure that out. What's happening? Your x squared power, you start with x squared, you go down to 1x, and then you have no x's.
Do they subtract on the line?
Yes, they do. Okay? You subtract them down the line. I like how Shields put that. Go on down the line and subtract them. Okay? So, you start from your x's, since they're first, and they're from Texas, right? Thanks for laughing while you're yawning. Appreciate that. That was a terrible teacher joke, but anyways. Terrible
I don't
teacher.
even know what you said.
I said, your x's that are from Texas.
All my exes live
I get it.
Thank you. Thank you. I'll be here for about another half hour or so.
All your exes live in Texas.
So this
in there. Song. She knows it.
which means this first x exponent that's on the 6 goes x to the 5th, and then we go to the 4th here on the 15. Then you go 3, you go 2, we go 1, and then on this term here it's x to the what? 0, which is 1. So you don't need it. Okay? Does that make sense?
I thought those were subtraction signs, not like the little.
No, those
I did too.
they're
I was really confused why you didn't just put them together, you know?
yeah, they're fill in the blanks. Sorry. I guess I should have made that clearer. My bad.
I thought.
I figured it out actually.
And what?
What's that
Shh,
wire?
shh, shh.
This is just X, right?
Just x, right. X goes from 6 on the left hand, and then you go down to 5, 4, 3, 2, 1, and then none, right?
It's vice versa.
Okay? Now your 6, your y's, yeah. Now your y's go the other way. You start from here and you go 6, and then you go down from there. 5, 4, 3, 2, 1. And then once again, a y to the 0, which makes you be just a 1. And that's your answer.
Wow.
Okay?
What is it?
That is
Right there. That whole line.
That's your answer?
That's your answer, that whole line.
Is it going to be solved like up the entire time?
No, we're going to change things up a little bit.
So
Well,
wait,
we
so
have
it's, so
problems
it's
like
not.
this on the test. They're like that long.
Yes. Okay. Here's where we are going with this. Okay, everybody, just kind of chill out for just a split second. Okay. We will go to problems. I will probably make you on a quiz or test expand one fully out one time. Okay. A little lengthy, a lot of writing, and let's be honest, I don't want to read all of it. Okay. That's a lot of little exponents to check that, in my opinion, are tedious to check. We will eventually get to problems where I ask you for specific terms of these. That's what we're going to do tomorrow. Okay? So I'll be like, tell me the third term of x plus y to the sixth, and you guys will tell me 15x to the fourth y squared. Okay? We'll talk about that tomorrow. Okay? We're also going to get to a problem where this second variable is a number. And that changes a few things about it also. Okay, so we will get to different variations of this, all of which I know takes a lot of time. So I am aware of that when I'm writing your quizzes / tests. Okay, Megan?
What is that exponent on the 6x at the very end?
On the which one? The 5?
On the very end.
This one?
Yeah.
That's a 1. I know. Yeah, it's. I can see it being a 1. I can see it being like a little
Kind of looks like a
smudge of a.
I put a 3 at first, but I just.
And then that's a 5. I don't even know what that looks like. Okay, so that's the basis of this. Okay. Somebody asked me last hour, well, would you be mad if I just put these all into my calculator and that way I had all the rows? I would not, but you would be wasting your time for reasons you will find out tomorrow.
Here.
Beautiful, beautiful program.
Here you go.
Is that the only one?
Now,
The next.
I lied to y'all.
We do have.
You do have homework.
And
It's okay. We honestly.
There we go.
Oh. You used to get rid of it, but it has
do you just look at
Is it just the same thing, but it's just.
That's what you guys need to figure out.
That's our homework.
That is your homework.
What if we don't figure
Here we
it
go.
out?
Do you want me to go get your?
Oh,
you want me to go get?
Okay. Now, everybody listen. Your homework is to figure this one out. Now, hopefully, you get about 99% of it. Or let's say 98%.
You get mad if you look it up on the internet.
Okay? Honestly, I will because you're not really learning. You're just doing homework that I'm not honestly going to even check and give you points for. So maybe take a little effort and try to figure it out on your own.
You're gonna get
Okay.
points this time?
No, you're not. Okay? Now, think about this. The exponent hasn't changed. The variables have not changed.
Well, the triangle changed.
The triangle won't change, which means the coefficients don't change. Okay? The number of terms you have won't change. There's still 7 because you always have one more than what this number is.
Yeah.
The only thing that changed is the sign in the middle. Figure out what that changes about your answer.
You want me to
Okay.
go get